In this learning target, we're going to learn how to factor quadratics with leading coefficient of 1. And in subsequent videos, we will solve quadratics by factoring, and also we'll use factoring to solve some real-life problems. To begin, we're going to start by reminding ourselves how to multiply, and more specifically, we're going to write down the steps for how to do that so we can understand the process of what we're doing, and then use that process to help us with this new skill called factoring. So recall, one way to multiply a polynomial like this is to use a box. So when I use a box, I do the following. I'm going to take each of the polynomials, I'm going to make a box by placing them on the outside. I'm going to make a box along the way. So again, our process is we're going to place the terms on the outside of the box. The next thing we did was we multiplied down and across, just like you would in a Punnett square in biology. This is multiply down and across. So I multiply to fill in this first box. I multiply this 2x with this 1x. 2 times 1x is 2. X times x is x squared. 2x times minus 2 is minus 4 and an x. 1 times x is positive 1x. And 1 times minus 2 is minus 2. So to complete this problem, I would take the terms on the inside. The next thing I do is my third step here is I take the terms on the inside. Just take the terms from the inside and add them. Meaning the terms on the inside are the 2x squared, the minus 4x, the plus 1x, and the minus 2. And the final thing I need to do is to combine the like terms. And it looks like the like terms are these two, and minus 4x plus 1x, there are minus 3x's left. So when I'm all said and done, I get these two binomials multiply to be 2x squared minus 3x minus 2. And that's great. Today, we're going to do the exact opposite. We're going to unmultiply, which is called factoring. To factor, we're going to do this in reverse. Okay. Which means we're going to start with a polynomial that looks like this, like a trinomial. We're going to focus on things that are trinomials over the next few lessons. We're going to take these and try to work through this process but backwards. So we're going to start by uncombining the like terms. Then we're going to take these things that are added and put them back into a box. We're going to figure out what multiplied down and across to make that box. And whatever was on the outside is going to be what is going to be the factors of this polynomial, or we're going to figure out what multiplied to make this. Okay. So let's take this process and we're going to do this, see how to put this to action. So here's a trinomial. I'm going to try to figure out how do I undo this process here. The first thing so if I'm going to undo, that means I need to go backwards through this. I need to go from, I need to move from the bottom to the top. Okay, so how should we do that? That means the first thing we need to do is undo this combining like terms. We need to figure out, we need to go figure out how we take this plus 3x and turn it into the two terms that were combined together to make it. And this is exactly those challenge problems that you hopefully worked on in previous lessons. Specifically, we're going to make ourselves a multiply and adding game. What are the things I'm going to multiply? I'm going to take the first and the last terms together, and I'm going to multiply them. And that's going to be my number that this pair that I need to come up with, this pair of numbers, needs to multiply to. So in this case, this is 2x squared. The add, is the middle term. So just like we were working on before, we worked on probably a couple days ago or maybe last week, we need to figure out what's a pair of expressions that multiplies to 2x squared but adds to 3x. So let's see, numbers that multiply 2, there's not many numbers that multiply 2, just 2 and 1. Can we add 2 and 1 to get to 3? Absolutely. So I think to multiply 2x squared and add to 3x, that's 2x and 1x. So this polynomial, if I uncombine this middle term, would be better written as x squared plus 2x plus 1x plus 2. That would be uncombining the like terms. The next thing I need to do is I need to now take these. I need to take these terms that used to be inside a box, and I need to put them back into the box if I'm going to again work backwards. So I'm going to make a box that has 4 entries, very, very similar to what we're using to multiply. So here's a box that has 4 entries. And I'm going to place these terms back into the box. The x squared term was always in the upper right hand corner, and this constant term was always in the bottom left hand corner, and I'm going to do the same thing with mine. So I have an x squared, I have a plus 2, and then these two terms can go either place here. It does not matter whether I put the 2 on the bottom or top. It doesn't matter. So I've taken the terms that were on the outside and put them back into a box. I've undone step 3 here. Let's undo step 2. I need to multiply down. Before we were multiplying down across, now I need to figure out what multiplies to make this box. Well, there's a lot of ways you can do that. Probably one way is to find what's the greatest common factor in each column and row, what's in common in each column, what's in common in each row, and write that off to the side. I like to start by just trying to find like one of those things. So like find one of these. It looks like me like 1, 2, 3, 4 spots. What would that entry have to be? And then the rest I'll kind of fill in from there. I look at what needs to go here. Whatever multiplies above the left-hand column is going to be in common in each of the 2 boxes below it. So what's in common in these first 2 boxes? Well, the only thing that they're shared between them is they're sharing an x. So I think an x has to go right here because x is in common here. From here, I can fill in the rest of these things. I know that if this is an x, then to make an x squared, I know this also has to be an x. I know that if to make a 2x here, I would take this x here and multiply it to this number, whatever number goes up front. So I think x times positive 2 makes 2x. Similarly down here, I think to multiply with an x to get plus 1x, I need a positive 1. To check that I did this right, I'm going to make sure that the two numbers I just, that what I filled in makes the answers inside this box. X times x is x squared, x times positive 2 is plus 2x, plus 1 times x is positive 1x, positive 1 times positive 2 is positive 2. So lastly, how does this original polynomial factor? It factors to be whatever was on the outside of this box. I think the terms on the outside of this box are x plus 2 and x plus 1. And voila. There's our polynomial factored. Let's try this again. Maybe a little faster this time. Let's see. And if I'm going to factor this, I need to figure out how to uncombine the like terms of the middle to turn this from a 3-term polynomial into the 4 terms that would end up in my box. Again, to do that, I'm going to make a multiply and add problem. The multiply is going to be what I'm going to multiply the outside terms. So that's 10 times a squared. The add is the middle term. And that is 7a. So I need to find a pair of numbers that multiplies to 10a squared but adds to 7a. Numbers that multiply to 10 are either 1 and 10 or 5 and 2. And what do you know? 5 plus 2 is 7. So I think the answers to my problem here are 5a and 2a. So I'm going to take this term and I'm going to uncombine the 7a by using the solutions to my little puzzle here. And now 7a was better written as 5a plus 2a. I'm going to take these terms, I'm going to put them into, these are the answers to a multiply question, so I'm going to put them back into the multiplying structure or box that that they initially came from. Again, the squared term usually starts up here at the top. The constant term that doesn't have any variables is almost always in the bottom left-hand corner whenever we multiply out. And then these two numbers are fill in wherever you want here. It does not matter which way you put them. I generally put the second one here and the third one here, but it does not matter. Next, I need to lastly, I'll finish this problem by figuring out what needs to be on the outside to make this box as an answer. And again, I'm going to do this by trying to pick one row or column and find what's in common there, and then from there I'll figure out the rest as I go. Again, I see in this first left-hand column that what's in common in this is that there's an a squared here and a 2a, and the only thing in common is an a. So from here, the rest is pretty straightforward. If the answer is a squared and one in the top is a, what needs to go here to make an a squared? It's got to be another a. To make plus 5a, I need to take this 1a, and I need a plus 5. To make plus 2a, I need to take the a up here with a plus 2. And I check to make sure I did this right by making sure that this last box is the two numbers I just filled in. Plus 2 times plus 5 is, in fact, plus 10. So this tells me that how does a squared, what multiplies to make a squared plus 5a plus 7a plus 10 is a plus 5 times a plus 2.